Hello, everybody. Hello, everybody, and welcome to this special live stream. Today, we are going to be doing a final project presentation ceremony. So, hello there. I hope everything is fine. Audio is fine. Video is fine. If somebody can confirm here in the chat, that would be great, so that we can continue without worrying about that. So, today we're going to have one presentation of one of the students who is Joel Trubatch. So, he's going to be presenting a project about vision-based cafe delivery. He's going to be integrating a perception concept with manipulation, and he's going to be working with a real robot based on our Starbucks cafeteria. So, I can see that people is confirming that everything is fine. So without further ado, I'm going to introduce Joel. So hello, Joel, all yours. Hello, hello.
Oh, can you hear me?
Yes, we can hear you. We can hear you. Yeah. So unfortunately, we don't have camera for Joel, but we can hear you and we can see your screen also. So you can start whenever you want.
One moment.
Can you hear me, Joel?
Okay, so if you can hear me, your audio is now muted, I guess.
Hello, can you hear me now,
Yep,
Joel?
yep, there we go.
Okay, yeah, so
Okay.
we can hear you, so you can continue.
Okay. So let me reshare this. Okay. So this project was pick and place task for a simulated cafe, grasping the cup and moving it to a fill position and then to a serve position with the barista bot you can see here on my screen. And so the equipment being used is the UR3E arm and the RG2 gripper. And then the primary software package used to sort of control it all is Move It To, and more specifically, their Move It task constructor. So in real life, serving coffee, depending on the setup, would either be an entirely structured task, but more likely it'd be a semi-structured task where you would have some elements dynamically entering and exiting the workspace or volume for the task. In this case, it's essentially an entirely structured task. There's no uncertainty in that sense. No one's going to walk up and grab anything on the table. So that eliminates some of the potential issues with a task like this. The different steps that are required, of course, would be to locate the cup in the volume, grasp the cup, and then move the cup to a fill position. And then due to the constraint of having to grasp the cup from the side to allow it to be filled, the cup then needs to be regrasped from above and to enable it to lower down to the serving position. And then, so once it's been regrasped, you move it to the serving position and then return back home. The implementation of this, again, as I said, Move It To is one of the primary things, along with the point cloud library for perception. Move It To integrates Octomap, which allows the camera to perceive the environment, but it is not, super interactive, and that's where the point cloud library comes into play, and that's used to actually identify the cup and locate it in space. Um, the pick and place task itself, the reason why Move It Task Constructor was chosen is that essentially the other option was to use the Move It C++ API, but by Picnic's own documentation, they say that that's depreciated for this type of usage, and that you should use Move It Task Constructor. So I went with what the actual software developers suggested and used their task constructor. The task constructor itself is designed to simplify task planning for whether it's pick and place or other motion tasks. It takes a general framework and groups everything into potential stages, and these stages allow you to create a task potentially much more quickly than if you were working from scratch, because you have sort of a foundation to build on in each section. The various stages will pass information to each other, either to the stage previous to them or the stage following them, um, or in some cases they just work between sort of fixed points of information, and this they solve all of the stages individually, and then the task constructor framework tries to link those together into one full plan. um, so for example, it would solve the kinematics for the grasping position while simultaneously attempting to figure out the actual path from its current position to that grasping position, and then it would try and link that to the next position, say the fill position, and so on and so forth. Um, this does generally seem to improve the idea of task planning. Um, However, it does add a layer of abstraction to everything, which when you add more abstraction, you do potentially cause more problems. Um, so one thing that is very interesting in a package that's designed for motion planning is that there's no delay possible. Everything is from position to position. So in theory, you could go in and control the actual uh, like the acceleration and velocity curves to sort of add a pseudo delay, but there's no way to just say, okay, after completing this stage, wait 5 seconds to do this thing. It's waiting to see if that motion has been completed, and then it will just move on. Um, so some of the challenges involved, we'll start with perception. Uh, is that of course, with Point Cloud Library, it's a pretty big library. It goes into a lot of detail, with computer vision stuff, and so that challenge is just a sort of a brute force challenge of spending the time with it to get the depth of knowledge to sort of understand what's going on, to if you have any issues to be able to resolve those. um, and then there's more technical issues, related to setup and the hardware and stuff like that. And that's primarily where we'll focus on that portion. Um, One issue that I was unable to pinpoint the source of, I suspect it's actually a little bit of Point Cloud Library, a little bit of Move It, is that when the cup is detected, the perception data is passed to create the object, um, that it would randomly assign the z-axis of the object to be up or down, um, which in the broad scope of things doesn't matter too much. It's a cylinder in this case, it's a simplified version of the cup. However, in terms of planning around that and relating to the object's orientation, it does change things. So the solution to that was to just uh, take the other perception values and use those and substitute in a fixed orientation value, because the cup is always going to be upright in this case, and fixing the orientation of z-axis being up, is not changing anything. Um, the in simulation, the camera data is relatively clean. Of course, this isn't an actual point cloud device. It's a depth camera doing translation into point cloud data. And this is really seen in the real sense, and when you're using the real camera, there's a fair amount of noise. And so if I can draw your attention to here, oops. So, so for example, here in the image itself, you can see right where my mouse is, there is apparently what appears to be an occupied space. This type of artifact or noise, we pretty much determined to be due to it not being a real point cloud device. It's trying to take these depth images and change them into point cloud. There was more significant versions of this, which appear to be related to shadowing and the lighting, and so that was handled by, as you can see here, adding more lighting to the scene to eliminate some of the shadows and sort of give it a more homogeneous and flat lighting effect. However, more interestingly, is all of these blue and purple voxels are below the counter where the camera cannot physically see. So there are some issues with using this sort of implementation where there's going to be some noise generated, and this noise is unclear exactly what was causing it. I suspect part of it may be that the work surface it's not polished aluminum, but it's relatively shiny, and that might be causing some issues there. And so that issue remains, and does cause occasional issues with the perception, where because it's detecting occupied volume below there, it seems to affect the detection of the cup. Not so much in position, but it seems to think that the cup occasionally is much taller than it actually is. And in that case, you just run it again, and it'll usually correct the second time. Overall, however, there is an issue with there's a little bit of a lack of computing power and resources available for this. And you can see here, as we're sitting, you'll see occasionally voxels appearing and disappearing, and that's the Octomap updating. And that should happen relatively quickly in real time. And particularly once all of the scene objects are generated, it should clear out everything that's not actually present there. However, this does not occur in real time for, I'm assuming, again, computing reasons. And so that does require one little extra step of either rerunning it or manually clearing the Octomap to prevent any random little areas being detected as occupied when they aren't actually occupied. Um, Additionally, there is a small issue that seems to be related to multi-threading, where when the vision processing is done, it's done in its own thread. And from my testing, I was able to determine it as soon as that thread spins up, that's where it's hanging. And I was able to optimize it to get it to go correctly, probably 75% of the time within a minute or two. However, this does seem to be a hardware limitation of some sort, as in my own local virtual machine, there is no issue related to that. And just based on from what I can tell, the hardware and stuff like that, it's it's not terrible hardware, but it's not quite enough to necessarily do really intensive tasks in real time. Um, so the pick and place is again is the main focus here, I guess. Um, and in that, the uh, biggest challenge was that the documentation for Move It To the is not complete, and Move It Task Constructor has even less documentation. Um, so it is possible to reference the Move It One documentation. However, there are enough changes between Move It One and Move It Two that it's not entirely helpful. Um, and then there are some issues which just relate to the design choices. So, for example, I touched on that sometimes information is being passed forward or backward within the stage, or between stages. And that leads to some non-linearity or non-sequential nature in the planning. So normally you might expect that if you have action A, B, C, that you would plan them in order A, B, C, and execute them in that order. However, due to the way Move It passes information in the stages, sometimes you might plan order A, C, B, and then it'll actually execute order A, B, C. Um, and this goes deeper even to some of the functions, uh, such as one of the functions is a Boolean function. It's labeled allow collisions, and as one might expect, its purpose is to enable or disable collision with objects in the scene between, in this case, the gripper and the cup. And passing the value of true to that Boolean function will then cause it in some cases to return false and in some cases to return true, depending on the directionality of that stage. And this is not something that's explicitly documented, and it's non-intuitive that something that you would expect based on its name and sort of overall function would always operate in the same manner. However, the one of the biggest places where I found at least the lack of documentation to be a hindrance is that Move It incorporates the Open Motion Planning Library, OMPL, and there are a huge list of parameters in that which are then used in Move It. However, there's very little documentation as to how those parameters are actually exposed. And so knowing that you can change a parameter is one thing. However, knowing where to change it, and how to set it is a different thing. And based on what I was able to find, there are times where the developers discuss, like, well, you would think that you would do it here, um, but it is actually under this section. Or you look at the Move It One documentation, and see, oh, this is what they were doing here, and you try and do that and Move It Two, and it's not there anymore. It's been moved someplace else. Um, then beyond that, uh, a really significant amount of time was spent trying to address the constrained task planning. Um, and as one would expect, the adding constraints to task planning, of course, is going to increase the time. Without any constraints, it plans in a matter of seconds. Um, but with constraints added for the orientation of the cup to make sure that, if it were actually filled with the liquid, that it wouldn't spill it. It adds time to the amount of either tens of minutes to not actually completing the planning. Um, and in this case, at first I was thinking, okay, well, maybe it's the default planner, and attempted to use multiple different planners to address that issue. However, it was planner agnostic essentially. This issue occurred, no matter what planner was being used. Um, and eventually, I did find a response from one of the developers that said, "Yeah, we know that this is a problem, but again, this isn't something that's in their actual documentation. You wouldn't know that they know that this is a problem, and that it should be handled in a specific way." Uh, so their suggested solution is to use a constraint manifold database. Um, However, uh, due to um, there is issues with installing Mongo database and some of the related packages. Um, I tried to solve it in another way, because in simulation, um, I didn't have any issues with this type of thing. Um, and so uh, the constraint issue was solved by I added a couple of steps to the path planning, and changed some of the locations for things a little bit. Um, and then added joint limits to the arms joints. By default, they're allowed to operate in effectively a continuous rotation mode, and that was limited to a single rotation of minus pi to pi, um, and uh, this incidentally improves all of the plans, constraint or not. Um, Without that, the planner does tend to pick sort of uh,
Hello, Joel, can you hear me?
arbitrary. Yes,
Okay, just a very quick interruption. So, would you mind maybe showing a bit of this in the code? For instance, where did you set these limits or the constraints that you are
sure.
talking about? Just to
Okay.
provide some more context, because
Um,
otherwise I think it's harder to follow just by
yeah.
listening. I think that that can provide some more interesting information to the people watching.
So um, here's one of the in the move it config file here. Um, One of the files that'll be generated is the joint limits. Um, And so here we get to the actual uh, arm joints, not the gripper. And so by default, this minimum and maximum position is not included, um, which effectively tells the planner that the arm can operate in a continuous rotation kind of manner. With this, it limits it to one complete revolution, um, and that changes the nature of how it tries to plan. Um, so one of the other things, like for example, here is the configuration file for OMPL and all of the planners. Um, and the some of these values, um, for example, in the here is the individual configuration. Uh, they have different values. Some of these values, like for example, enforced joint model state space, um, or multi-query planning, in the Move It One documentation, those can be put into the actual planner uh, parameters. In this case, that does not work so well, and they have to be put here with the actual what planning group it is. Um, Similarly, some of those parameters uh, you could potentially put just in the general uh, configuration, like before, without any specific labeling. And that's what I was referring to before with there are a lot of different parameters for OMPL, and some of them have to be put into this general, some of them can be put in with the whatever planning group it is, some of them can actually be put into the specific planner type, and it's not always spelled out exactly where and how that should be done. Um, you know, Similarly, you have stuff like the sensor parameters, which is relatively straightforward. Um, but again, here it's passing parameters from Octomap, uh, but it doesn't. They don't necessarily document which parameters are able to be passed via this section and that section. Um, does that clarify things?
Yeah, yeah. Thanks.
Yeah.
Thanks, Gerald.
Okay. Okay. And so the fixing the constraint issue, uh, once that was understood, was relatively easy. The default planner is not an optimal planner. Um, However, with there is some basic constraints built into using a place stage. So it will try to keep the object in the same orientation at the end destination as it was picked up in. Um, and so once the joint limits were enforced, um, even though it's not an optimal planner, it by default comes up with relatively optimal plans that also keep the constraint in place because it would it just logically speaking it would take more effort to swing the coffee cup upside down by accident or something, um, than to not. And so here, if you note here, So here I've run the actual task here, and as you can see, it's waiting on perception, and it should actually continue to tick by, but it times out at some point. Essentially, it's not a hard timeout, but something happens in terms of the trying to process that data. So in that case, the easiest thing is to just restart it. Because again, that, as far as I can tell, is a hardware limitation, um, and not a software thing. Um, so once this gets going, um, you'll see the scene objects come into play. One of the, I guess, more minor things is that in this case, we're using a single camera that, given the methods uh, that were directed to be used, there's no particularly good place to put that single camera to capture everything that's necessary. Um, so, for example, if the camera were on the leading edge of the counter towards where it's going to be served, so that it could see in the space under the coffee machine to fully detect that, um, it would be potentially hit or knocked over by the movement and the motion planning. Um, Similarly, where it is, it can't actually, this void here next to where my mouse is, it can't actually see most of the coffee machine. Um, and so that causes the need to actually insert models or objects into the planning scene here, um, which uh, just takes a little bit of extra to do that. Um, but the perception does not seem to be catching. Let me give it one more go here. Um, okay. Um, so the adding the models in is a pretty trivial task. They don't have to be super detailed, um, just enough so that you actually can see some of the things that are going on. Some of the items, such as there's a handle on the work surface and clamps holding the work surface down, due to the noise and stuff like that, those definitely need to be added in, because when even just the cup is added in order to ensure that any noise around the cup is eliminated, it should clear the entire volume around the cup, which in this case would potentially impact the handle, or even the counter. Uh, and the planner relies on that information to not try and plan through a solid object. Um, so here it seems like something is hung up with the perception. Um, so let me turn that off briefly, um, just so it can be seen what's actually going on here. Um, and then, okay. Okay. Um, so the um sorry, lost my train of thought. So in terms of things that could be done essentially to streamline this, um, the it seems like the conversion from a basic depth camera to point cloud and point cloud data, no matter what, is point cloud data is tough to deal with under the best of circumstances. Um, and in this case, the precision that's available is not necessarily the best for this kind of task. Um, in in a more optimized implementation of this, uh, an overhead camera and basic computer vision with like OpenCV would work much better to detect the cup. The cup, even if you have small, medium, large, they're going to be known sizes. Um, and so you don't need to do the full object recognition and breakdown in that case. You just need to detect the location of the cup, which could be relatively easy by detecting the circle that is the cup, um, and the precision available to find the center point of that circle is much higher than at least with what's available converting a depth camera to point cloud, and doing all of that processing. um, and so that would be one thing that could be sort of done to uh, potentially uh, ease some of the computational load and actually make it more precise. So here you can see um, it failed one of the stages because even though it spawned in all of these objects, there's still Octomap did not fully update. It should actually, on creation of objects, it should clear the space around the objects to begin with. But and if we sat here for 5 or 10 minutes, it would actually clear it on its own. Um, However, again, there is some sort of limitation there. So if we manually clear it, um, then we can restart it um, and get it with a cleared version there. Um, okay, so here you can see the visual didn't actually update, but it did update in the data sense. Um, and you can see it's going through the what is happened to be the first, but also is the lowest cost plan. Um, it will still occasionally plan item, some sort of motion that breaks the constraints. However, the majority of the time it does succeed in doing that, and anything under 100 is pretty much guaranteed to be correct. Over 100, it might get a little weird. So here we'll go ahead and we'll run that. And so you can focus on the actual camera view. Um, um, okay, so it's giving me a synchronization error. Um, was something left on sim time when the robot was used for this other thing?
Nope.
No?
No,
Okay.
no.
So let me restart everything and
Yeah, let's try that.
check that. So it looks like the joint state broadcaster has failed.
Hello, Joel.
Yep.
What's that? You are not getting the initial state of the
So
arm, or?
the joint state broadcaster, like you can see here, it's
Mhm.
it's not running.
Okay, let me try to restart the drivers from the real robot side.
Okay.
Okay, give me just 30 seconds.
In the meantime, we can see Alberto that is there trying to reset the controllers for Joel. So, Joel, you have made some claims before. Okay, so Alberto, we have it here restarted. Yeah. So okay, so let's wait the questions for later then.
Okay. It's still not broadcasting joint states.
Okay, can you try maybe disconnecting and reconnecting through the real robot lab. Close
Yep.
things and let's try that. Can you try to echo the joint states topic to have a quick look?
Yeah. Let's see.
Okay.
It seems to be working again based on the
Looks
position
like, yeah.
there.
Okay.
Okay.
Let's go for it then.
Okay. So now it's planning again. Um, what? Where did? There it goes. Okay. Okay. So here we'll execute that.
So what is going on now?
It should be, it's just doing the initial open close of the gripper to, sort of just check that position. So here you can see it's approaching the cup, closing on the cup. And again, you can see that the cup itself deforms pretty significantly. This, would be addressed by having fully operational drivers for the gripper so that it's not sort of operating in a, I guess, dumb mode would be the best way to put it. And it looks like it crushed the cup a little bit. So that is one of the things discussed when the cup moves around because it springs back into position. It sometimes goes out of position from where the cup is expected to be, and then the gripper doesn't know where it is actually. So that again in part would be solved by we have the minor workaround of trying to reinforce the cup, but then the gripper actually stopping with less pressure. And then other sort of real world factors that would go on would be adjusting the acceleration and the velocity so that once the cup is filled, you're not sloshing the liquid inside. So it's reset. We'll execute again. And these are things that you can adjust for a real world use case. And as I noted, there's no actual way to pause this. So in an actual real world use case, move it task constructor would not be ideal because stopping under to actually fill is not possible in this, or at least not easily possible in a way that makes sense. Oh, so we're interacting a little bit with the cup there. So I can speak on that, which is when it interacts with the cup like that, it knows where the cup is. However, there are some discrepancies between the model being used here in the back end of Move It and the actual gripper position and stuff like that. Which this came down to the gripper by default. The RG2 gripper expects a 0 to, what was it? 160 value, I think, was those were the, it's a value in millimeters for the opening, whereas ROS and everything else on the back end, so the actual model is constructed using what's presumably radian values of, like 0.4, minus 0.4. And so while we did go through and attempt a matching between those things, there are some discrepancies there due to the lack of drivers and not actually having the full the model being exactly precise there. But even in those cases, it's usually not trying to plan so tightly around things that it interacts too much with it. So I guess any questions or?
Okay, Joel, yeah, so I was going to stop you there so that we can have some time for Q&A. Thanks for the presentation. Then, yeah, so for people who is even watching here the stream, you can post your presentations here in the YouTube chat. I'm going to start with one myself to give some time for everybody to create questions. So there we go. Okay. Yeah, so unfortunately we cannot see Joel, but we can hear him, which is the important thing. So yeah, I wanted you to explain a bit more about this movie task constructor, because for me it's not clear. So basically, so what is it? It's something that goes on top of Moveit. It is something that allows you to create tasks and then organize them easily. So what is exactly the purpose of it?
Yeah, so it's a framework, I guess is the best way to put it, created by Picnic, the people who made Move It. And their reasoning was to simplify task planning and task creation. So for example, in Move It, you to say move to a position, you would have to create multiple lines of code, and there wouldn't necessarily be an easy way to pass information from one section to the next section. And each section would have to be tested more thoroughly individually. So while in this case, it is certainly possible for individual sections to fail, and unfortunately, there's not a lot of feedback about why they're failing. It does at least pinpoint sort of what's happening in that sense of where it stops and where it starts, and it makes it much faster. For example, to do certain portions. So let me reshare my screen real quick. So for example, this is the initial portion of what's going on. And so here is opening the grip or closing the gripper and then opening it again. And I just have that there just in case for some reason there's a physical discrepancy between what's expected and what's actually happening. And you can see that it's a relatively short little thing where this is just adding that stage to the task, and this defines what's actually happening. So here you can see they have stages built in. In this case, it's a move to. I specify which type of planner. And so in this case, it's just a basic planner that's trying to go between two positions. And since this is just a gripper open and closed, it doesn't use a very comprehensive one. And so these pass information forward. So like this, any information generated by this would automatically be passed to the next stage here. This stage goes from that initial arm position to the grasp stage. And so this is a connector stage, as they call it. This doesn't technically pass any information. It just tries to solve between two positions. And then here, you can add stages to a larger structure called a container. You can see here we're taking properties and configuration information and passing it along. And this you can actually see touches on sort of that non-linear, a little bit of that non-linearity, where normally if you were thinking about how to approach something, you would think go to the thing in that initial sort of pre-position and then move closer to it for that final positioning and then do whatever you're going to do. Here, this stage of that approaching the cup actually comes before you figure out where the cup is essentially. And so normally you might think that this, generating the grasp pose itself would come first, and then you would approach the cup. Whereas here you approach the cup, generate the grasp pose, but it sorts these out internally because as I said, there's directionality to the stages.
Okay,
And so
I think we are getting too deep into that. So
okay.
In simple terms, could you tell me, would you recommend using it or it's not worth it? You can do basically the same just by using Move It APIs.
If you are working within the framework of Move It, I would recommend it. It is clearly the direction that the Picnic developers, decided to go in. And to just put together some sort of task and motion planning, as long as you don't bump into some of the constraints, such as needing to pause, and even that you could sort of work around it with some creative utilization, I guess. That yeah, it is overall much more effective, I would say. It puts things into clean sections, and given if you're working with ROS1 and Move It one, I might say just stick with the C++ API, because there is more documentation there, and you do have a little bit more, like you could put just a pause in there. However, for overall planning, especially in ROS 2, I would actually still use this if I were using Move It specifically, because it does provide a much faster framework to put in all of these different parameters and make sure that things are getting passed from one to the other, especially once that initial sort of learning curve is overcome.
Okay. Okay, thanks, Joel. So let's move to others because there are some other questions here. For instance, let's go for this one. A question from Miguel. So the perception, your perception system, what is doing exactly? It is detecting a cylinder shape in a zone, or you are clustering a big blob of voxels to consider the cube. Is that done?
So
is that done by you, or you're using something which is already provided?
So the voxels that you see in RViz, that's Octomap. And so that's just in terms of what's happening in the task, that's just the environment being sensed. And it doesn't provide any additional utility beyond that. To actually detect the cup itself, point cloud library is being used. And so the basic steps of point cloud library, or working within that, is I didn't do anything fancy. There are multiple ways to do object detection in point cloud library, but this is a pretty straightforward look for a geometric shape kind of thing. So first thing that happens is that filter all of the data down to a certain region, and then within that region, find the planar surface, the counter, and then remove all of that, and then process the remaining point cloud data, which in this case it's going to look for something that is roughly cylinder shaped, being the cup. And it sees that and it takes measurements, or I guess it takes various data points to create the measurements and the orientation. So it takes points from the top of the cup and from the bottom of the cup, where it's perceived to be the bottom of the cup, and it uses those to create the radius and the height, and then the orientation and position.
Okay, and let me link this with Girish questions, because does this perception really work? Is it reliable? Because Girish is asking, okay, so if you are using this perception, then why do we need the cup to be on the X marked spot?
So the X marked spot was just for my own purposes, and I mean just in general, to eliminate any potential issues. The best way to put it is that the perception method itself is reliable. The camera data is not. So I did notice that, for example, if the cup is moved much closer to the camera, it becomes much less reliable. And it has more issues with dealing with the errant sort of noise below the counter. And the having just a place to put it sort of eliminates some of the need to troubleshoot, is this thing or that thing, is this one thing or the other thing. The tweaking sort of the perception, what's going on as far as the ability to filter things, that's certainly possible, you could do additional filtering to try and get a cleaner thing. It would benefit highly from being able to run the actual point cloud overlay to see what's happening in RViz in the actual point cloud. But running that at the same time as doing everything else really tends to bog down the system and cause problems. And so to do some sort of pre-extraction or extraction and see what's being extracted and then rerun it if it's not the correct thing, it would take more computational power than's really available at the moment. I mean, well, at least on the server.
Okay, what would you suggest, or what would you do in order to have a more reliable perception system? You commented earlier a bit about maybe using OpenCV.
Yeah. I mean, if in this case, the benefits of using a point cloud are not really there. The main benefits of using sort of point cloud or even 3D data is where there would be a lot of unknown and the accuracy and precision isn't the primary thing that's necessary. So say you're navigating a mobile robot, whether or not it's precise down to a few centimeters, it's probably not super critical. You just don't go that close to an obstacle. But however, to grasp something, like a cup, you need the precision, the accuracy to be there, and for there not to be artifacts and noise. And relatively speaking, a flat image, returns, whatever 800 by 400 points of data. The point cloud is, exponentially more than that. So yeah, by just using something like OpenCV, you could run, like, even if it's not directly overhead, but a sort of a high angle view, you'd run circle detection, find the circle, locate the center of that circle, do some translation between the known position of the camera, so you know where that circle is relative to the camera and in the world. And that precision, again, because you're essentially counting pixels, which turn into fractions of a millimeter, is much higher. And you're not going to have the same kind of noise and potential issues there that you would trying to deal with the relatively heavy load of point cloud data.
All right. Then thanks, Jared. I think we're going to leave it here.
Okay.
So, do you want to say some final words?
Not that I can really think of at the moment. Overall, it seems like, this could be, I guess, reconfigured a little bit in terms of, there is the cup holder right there, which might not actually be in reach of where the arm is at the moment, and would require a slightly different, planning around grasping, since you would likely grasp the cup at an angle, which would be an interesting problem to solve. But in terms of the way this is set up as a project and a problem to solve, it's sort of halfway between the academic version and the practical version, in that if you're solving it to do it in a real setting, you would optimize certain things to eliminate a lot of the uncertainty. For example, the cup would always be in the same place. You could have multiple size cups, but they would always be in the same place because they would be, say, in the cup dispenser or on the stack of cups or whatever. And you would adjust the environment to specifically fit the task, because there's no reason not to if you're doing it to actually get a hot cup of coffee to a serving position. Whereas the academic version, you leave more stuff, a little open-ended, to allow for, I guess, a little bit more robust problem solving. However, it does introduce a lot more uncertainty, and it introduces, issues that, as I said, can be solved not with robotics, but just by pre-planning something.
All right. Yeah, so thanks for your presentation, Joel. I hope that people liked it and enjoyed this presentation. Yeah, so before, sorry. There we go. Yeah, so before closing, let me tell you that we are going to have some more final project presentations by the end of February. So stay tuned for more presentations of our students. There are many different things, many different interesting projects. So I'm sure you are going to enjoy them. You are going to learn a lot from them. So yeah, see you soon. And as always, keep pushing your ROS learning. Bye-bye.